In this demo we are going to showcase how Big Cloud Fabric can run multiple virtualized OpenStack pods. Big Cloud Fabric is a leaf-spine class fabric with optional vSwitches, inspired by Google's Project Andromeda. You can put any IP address anywhere and use distributed logical routing between segments to establish the connectivity between virtual pods. Instead of managing all these switches one by one, using Big Cloud Fabric SDN controller, you can manage the whole network like a one big switch using CLI, GUI or REST APIs. Furthermore, BCF provides tight integrations with OpenStack and VMware. Here is how BCF enables logical virtual pod functionality with a single physical fabric. Using tenants and logical segments, BCF provides logical isolation between tenants. Therefore, a single physical pod can be segmented into multiple vPODs. BCF's orchestration integration allows multiple isolated OpenStack instances, and multiple vCenter instances, to run in parallel. BCF's fully distributed logical system router function is used to connect vPODs to each other, or to critical infrastructure with routes and policy. Because of this logical isolation, vPODs can have overlapping IP address spaces and overlapping VLAN tags. If you happen to find yourself in need for more capacity, these logical segments in a vPOD can span across multiple physical pods by using hardware-based VXLAN tunneling. As a result, your OpenStack instances would be able to utilize hardware resources from multiple physical BCF pods. Before we go into the demo, let's put it all together. BCF provides scale-out core and pod design for large-scale production networks. Logical vPOD design enables dev and QA tenants to test different orchestration versions or different configurations in parallel. These vPODs can span multiple physical pods for distributed labs, overflow or migration purposes. For the demo, we have 3 rack BCF topology. Each rack has 2 top-of-the-rack leaf switches. And all those leaf switches are connected to spine switches on top. We have 4 bare metal servers connected to the first 2 racks. Third rack is used as a service rack. In this step we will bring up our first vPOD. We will bring up a fuel master node in the service rack. And we will assign first 3 bare metal servers in the first rack as controller and compute nodes. However, before we bring up this vPOD, we need to provision BCF, in order for the fuel master and 3 bare metal hosts to get discovered by each other. BCF provides an easy way to enable this auto-discovery in the fabric, and later provision these hosts into different tenants. We'll go ahead and create a tenant called management in BCF, and provision it, so that it looks for any untagged traffic coming into the fabric. Let's go ahead and log into the Big Cloud Fabric. Next, we will go into the tenant section and create a tenant. We will name the tenant as management, and provide a short description. Next step is to go inside this tenant and create a logical segment. Logical segment is analogous to a VLAN in the traditional networking world. We will name this segment as Pixie. This segment will enable Pixie communication between nodes. Next, we will go inside this Pixie segment and add membership rules. These rules will tell BCF to look out for any untagged traffic appear on any of the switch interfaces or port group interfaces. As a result, all the untagged traffic is getting used for Pixie communication will get classified under this tenant, management, and segment, Pixie. Now we are ready to provision our first Mirantis Fuel vPOD. We will go ahead and bring up a Fuel Master as a VM inside the service rack. And all the bare metal hosts should be able to Pixie boot and bootstrap using the Fuel Master. Let's go ahead and verify we can log into the Fuel Master and we can indeed see the 3 bare metal hosts. As you can see here, we can see those 3 bare metal hosts are appearing under Nodes section of the Fuel Master. Now, we should be able to deploy a new OpenStack environment using these nodes. However, before we do that, what we are going to do next is isolate this environment using BCF, so that we would be able to assign this logical vPOD to a particular user. If we go back to the BCF, and expand the endpoint section of the Pixie segment, we will see all 4 endpoints. Fuel Master and 3 bare metal hosts appear here. In order to provide an isolated environment to a developer, all we need to do now is to create a new tenant using these 4 attachment points. This will essentially provide a logical vPOD to this developer, and whatever action he or she performs will be isolated within this logical vPOD. Let's go ahead and create a new tenant. We will name this tenant as Dev1. Inside this tenant we will create a segment called Pixie. Our goal is to move all 4 host endpoints we saw inside the previous management tenant, Pixie segment, into this Dev1 tenant. Now we will add all the attachment points we saw before into this segment. We will add the specific port group membership as well as the specific leaf switch interface membership. If you recall, in the management tenant, we were adding these membership rules using any keyword. But over here we are being more specific now. Now we can see all those previous host endpoints are appearing under this Dev1 tenant. We are now ready to hand this logical vPOD setup to the Dev1 tenant. Whatever this user performs will be isolated inside this tenant. Dev1 tenant can log into the Fuel Master node, and will be able to start the OpenStack deployment. Furthermore, as a cloud admin, you would be able to create more segments for extra networking needs of this tenant. For example, common OpenStack use case would be to create 3 more segments for public, storage, and management. If we go inside the Dev1 Fuel environment, we would see all 3 nodes are ready to provision. If you go inside the network section, you will also see Dev1 tenant had created multiple networking segments according to their needs. As mentioned before, in order to enable these custom networking needs, all you need to do is to create more segments in the BCF under the Dev1 tenant. You will also be able to provide external networking connectivity to this Dev1 tenant by attaching external links as membership rules. Let's recap what we did so far. In this step we brought up a Fuel setup with 3 nodes and assigned it to a tenant called Dev1. In the next step we will bring up another Fuel setup for a QA tenant and assign 3 bare metal servers to the setup. However, in this step we will also add couple ESXi hosts as compute hosts, through a vCenter server instance connected to the BCF controller. Furthermore, instead of using BCF GUI we will use REST API to provision extra nodes automatically into a new tenant. Let's go ahead and boot up the second Fuel Master node. And we will also power up the 3 bare metal hosts and let them Pixie boot through the second Fuel Master. For this step we don't need any new configurations. Since we already created management tenant, all communication should automatically happen through its Pixie segment. Let's go ahead and look inside the management tenant, and make sure BCF is discovering these endpoints. We can see 4 new endpoints are discovered here. Let's also make sure we can access the new Fuel Master node. This Fuel Master node should be able to discover all its corresponding nodes. Everything looks good on the new Fuel Master node. Now we'll go one more step and configure a VMware vCenter server in this Fuel Master node. This vCenter server and its ESXi hosts are connected to the BCF using BCF's VMware integration. As a result, as soon as the deployment is done through the Fuel Master, OpenStack cluster would be able to fully function automatically between both Ubuntu compute nodes and ESXi compute nodes. Before we start the deployment, we'll allocate this vPOD to QA1 tenant. Instead of doing this through the GUI, we will do it programmatically through REST API. All the functionalities in BCF is programmable through REST API. In fact, both GUI and CLI use this underneath REST API to get its work done. The idea for us is to see how we can automate these manual vPOD provisioning tasks. We will write down the MAC address of each new host and programmatically assign these MACs into a new tenant. Here are the MAC addresses we will need for the next step. We will use these MAC addresses as input parameters to our small Python script. The script will essentially perform following functions. It will first log into the big cloud fabric using the credentials provided. Then it will look whether these MAC addresses appear inside the management tenant. If it finds these MAC addresses, then it will create membership rules inside a user-defined tenant, in this case tenant QA1, using the corresponding switch or port group interfaces. This concludes the Big Cloud Fabric Lab Manager solution demo. As you can see, BCF provides unique and easy way to provision virtual pods for both OpenStack and VMware. You would be able to utilize either the BCF GUI, or BCF CLI, as well as REST API-based programming to quickly carve out virtual pods for your dev and QA workloads.